Okay, welcome everybody, and thank you so much for joining our webinar, which is called Designing for Decades, Lessons from the Field for Long-Term Renewable Energy Project Success, where we're going to be discussing projects built to stand the test of time. Information today is going to be presented by Enertis Applus, which is an independent advisory firm, Radian Generation, which is a comprehensive asset management platform, and SolarGrade, which is a software product that streamlines QA/QC, site inspections, and reporting. Next slide, please. All right. I'd be remiss if I didn't first mention the importance of energy modeling, EYAs in general. If energy modeling is done inaccurately, if it's overestimated, a project is doomed to fail from the beginning. It's doomed to never reach its generation goals. But for the purpose of today's webinar, we're going to be taking that for granted and focusing on the physical failures that can manifest if early design is not paid attention to and mistakes aren't caught early and often. So specifically, we're going to be talking about design phase risk drivers, construction oversight, quality governance, commissioning rigor and grid compliance, grid code compliance, turnover discipline, warranty protection, and long-term operations performance optimization and repowering strategies. Next slide, please. And we're going to be doing all of that in the context of current market conditions where we're seeing rising capital costs, where whether fixed tilt tracker or commercial PV, we're seeing about a 10% year-over-year increase. That in turn causes lending to be generally conservative, generally selective, and the implications for the projects is that there is less margin for error. There's less tolerance for change orders, less tolerance for yield shortfalls, et cetera. Next slide, please. And I'm going to start with a little audience participation. So if you can please answer the following poll question. Have you ever experienced a post-COD defect that materially affected refinancing, reserves, or valuation? And while you guys are answering that question, I'm going to leave you all with an anecdote from my time as a tracker vendor. I spent about 10 years as a tracker vendor before joining Enertis Applus. And there was one interesting time where I was in a competitive bid for about a 100-megawatt project where I lost the bid to a competitor that won on price. And somewhat unsurprisingly, they had some oversights, and one seemingly small oversight actually caused really huge problems for the owner. And it was one that seemed, again, so minor just because the vendor failed to color code their components that they were delivering. And specifically, they didn't color code their piles. And in so doing, the EPC couldn't distinguish between simple and motor piles. They installed all the piles without respect to where they should be positioned, and then built the trackers on top of that, which then caused them to have to backtrack, pull them all out. And the end result was that they incurred more than $10 million in cost to remedy, and they lost about 7 months of schedule slip. So I say all that for a couple of reasons. It's a perfect example of catching something early that saves you big time in the future. And at Enertis, we would have 3 lines of defense against this kind of thing. We would catch it in our RFP designs that we consult or we advise our customers on when they design their RFPs going out to EPCs. We would catch it at the supply chain level when we do factory acceptance tests and witness tests. And then lastly, we would catch it during construction monitoring and on-site service. We would see that kind of mistake happening in the field, and we wouldn't allow it to just snowball out of control. So perfect example of an old adage, an ounce of prevention is worth a pound of cure. And that is what today's webinar is going to so closely follow. Next slide, please. And with that being said, I'm going to introduce our speakers. So I'll start with myself. I'm Colin Caulfield, the Business Development Director at Enertis Applus. With me is Ed Johnson, who's the Director of Owner's Engineering, also at Enertis Applus. We've got David Penalva, the CEO of SolarGrade, and Aaron Kivlahan, the SVP of Asset Management at Radian Generation. Next slide, please. And with all that being said, I'm going to pass the mic over to Ed, and he's going to get started on telling us about life cycle costs and why early action is so important. Thanks so much.
Great. Thank you very much, Colin. Here at Enertis, we have a unique role. So we really get to see the entire life cycle. So we're involved early at the design phase where we're doing design reviews, constructability reviews. We get to move on to construction and commissioning, where we're doing construction oversight, commissioning review, commissioning, I don't say design, but commissioning, standardization and evaluation for the customer. And then we also get pulled in after operation, after commercial operation, where we'll get questions and our clients will reach out to us for support for analyzing issues and looking for root causes. So what that really allows us to see is patterns. If you're just individually at the different phases at the beginning, they may just be data points. But if you're able to see these issues in the preliminary and construction phases, and then also come back after operation and see how these issues are manifesting as, impacts to production and revenue and whatnot, it really gives us a holistic picture and a unique perspective. So, with that, kind of bring us to our kind of the key point that I think really underpins some of what we're saying today. Go to the next slide. And that is when it comes to risk, timing dominates economics. A small issue, an issue caught at early phases, just results in essentially additional design activities, maybe studies. However, if that issue is not caught in design, it definitely snowballs at the construction phase, and you've got rework, you've got, remobilization costs, you've got, a variety of things that can happen during construction. And then if it passes through design, if it passes through construction and moves on into commissioning, now if the issue is found there, now you're looking at retesting. You're looking at outages, potential outage issues. You're looking at schedule delays. You're looking at you know, variety of things on the commissioning phase. So if it's not caught at design, it's not caught at construction, and then also isn't caught at commissioning, the next place that it's going to get caught and where it's going to arise is in turnover and operation. And that's definitely where you do not want to be catching issues. Now you're looking at substantial lost energy. You're looking at, potential financing issues if it's, affecting the revenues and the cash flows. You're looking at potential warranty issues now if you don't have the documentation and things like that. So, like Colin mentioned earlier, an ounce of prevention is really worth a pound of cure. And these, like I said, yeah, if you focus on the chart, you can see that these ratios they really compound, right? Engineering studies, so those are relatively cheap. Construction 5 to 10x of 5 to 10x outages, 10 to 15. And I said these aren't just theoretical pie in the sky sort of ratios. They're really based on, mobilization costs, outages, lost revenue. So they are very real numbers that can affect the health of and evaluation of the project. All right. So now we'll talk about a few issues that we have seen in the field. If you go on to the next slide. Yeah, one of my favorite, I'm not a civil guy, I'm an electrical guy, but this is one of the things that's near and dear to my heart. I actually had a colleague tell me years ago that the most dangerous projects are the ones that really appear where the sites appear uniform. When it comes to these types of sites, the assumptions are made that the entire site is flat, and that you don't have to do. I don't say that the maybe the intense additional rigor of additional geotechs aren't really necessary. So what we've seen, I'm sure people have run into this. You have an early project, site's flat. They do preliminary borings. Maybe they're spaced far apart. It moves on to later in the project, and for schedule pressure, cost pressure, whatnot, or just poor assumptions, or not poor assumptions, but inaccurate assumptions. They once again kind of space the bores far apart. And then what can happen is that you can definitely miss heterogeneous soils. And in that case, you're kind of stuck. not necessarily stuck, but you've got substantial issues. You run into power fuse with things like, you may have to retrofit the site. If if those aren't caught, you can end up with alignment issues. So catching it early is really key. And if those types of issues may not just arise in construction, but also in the operation. Once again, like I said, with potential alignment issues and increased maintenance and potential warranty issues if it wasn't installed correctly. Um, so, like I said, we have seen things like this in the field. Like I said we had one site where the geotech resulted in roughly 50% of the piles having to be refusals on approximately 50% of the piles, and that is a substantial cost and schedule impact, and it does invite additional scrutiny from the lenders, from the IEs, and just all parties concerned. All right, next one. And these issues don't just arise from the civil side; they can also arise from the structural side. This is a situation that we've run into before. Um, Once again, another anecdote I've heard is that, the wind models follow equations. However, the wind follows the terrain. So what I say all that to say is that the actual site conditions must really be taken into account when it comes to wind modeling. We have seen sites that were assumed to be flat, and there was potentially an escarpment right outside the site, and that escarpment was definitely having an impact on the on the uh, on the wind profile on the site, and potentially is impacting the structural, excuse me, the racking stability and the stability of the structures. So what we have seen in situations like I mentioned is really just conservative assumptions in complex or really environmentally driven terrain, which is potentially, excuse me, not potentially, but is could be potentially not an issue in areas such as the Northwest, California, the plains in particular, where winds are pretty substantial. So, like I say, if you can, this is not a photo from that one of those situations, but like I said, it can definitely have a detrimental effect on the stability of the racking. And once again, if these issues have been caught earlier, you're looking at a maybe 20 or $30,000 additional charge as opposed to millions of dollars in lost revenue and repairs from a racking failure. Now, kind of summarize what we're seeing. Um, the kind of the base premise here is that these issues that, like I said, these design assumptions can definitely result in lost energy. And what we definitely encourage is that if there is a big issue, and which typically there is, but basically to increase the resolution if any variability can't be undone. And this isn't just for civil issues or structural issues, it's really anywhere on the site. Um, the next part is really consider targeted diligence. So, for instance, with the boring issue, maybe you don't need to increase bores across the entire site, just in some of the more higher risk areas, maybe in the drainage or the steeper slopes or some of those areas where they'll have the most impact. Next real recommendation is really challenge those conservative assumptions. So, something is um, right on the edge. If it requires conservative wind assumptions to be profitable or to pencil, then I think those assumptions are worth challenging. And the last one is really treating any early anomalies as potential design issues, not just construction noise. So. Um, with that, we'd like to ask if, got a poll question to really understand what the market is prioritizing. This will definitely help us understand what you and your partners are facing um, out in terms of the challenges of the project. So, with that, now that I've kind of handled discussed some of the design issues, we're going to move forward to life cycle and David is going to discuss some of the issues that he's seeing in the field.
Thank you, Ed. Next slide, please. Hi, everyone. My name is David Penalba. I'm the CEO and co-founder of SolarGrade, a fieldwork management software application that currently supports over 80 gigawatts of renewable energy assets. I founded SolarGrade after realizing the importance of field data in underperforming assets. Take into account when a data acquisition system sends alerts on overall underperformance, is typically a manifestation of a deeper technical problem. And without the field data, it is very difficult to close that loop. SolarGrade allows you to streamline fieldwork data collection, automate reporting, and produce meaningful analytics and insights. And today, I'm going to be presenting field data collected by our sister company, Heliovolta. That is an engineering services company specialized in field inspections and third-party quality assurance and quality control. They've been using SolarGrade for years, and they collected more than 300,000 quality data points on over 5 gigawatts of projects, with more than 2,000 inspections across the US, on projects ranging all the way from 500 kilowatts to 300 megawatts. When Heliovolta collects data, they assign a severity level to their findings, all the way from negligible to critical. Next slide, please. So the first thing I did in preparation for this webinar was looking at our database and see where the majority of the critical issues were coming from. A critical issue is a nonconformity that requires immediate action due to its consequences for safety and performance. And these critical issues directly correlate with partial or total downtime, and therefore underperformance. In this chart, we present the most common critical issues by project stage: construction in dark blue and operations in yellow. And the highlight of the chart is that 70% of the critical issues that we see in the field are related to thermal failures that directly correlate to underperformance. Next slide. Yeah. But when we ask where those issues are located within the system, we see that over 50% of the critical issues are located in the DC distribution, basically anywhere from the solar module to the inverter. That is, connectors, strings, cabling, DC harnesses, grounding, combiner boxes, cell combiners, etc. The DC distribution is the weakest link in the chain and is typically overlooked and not well thought out. This is due to its low capex when compared with other larger equipment like models, inverters, or trackers. And additionally, it is the last step in the construction process and is often rushed and affected by schedule constraints. On the right, we can see a few examples of the most common issues identified during the construction phase. These are wire management issues, connectors, grounding, wire terminations, labeling, etc. Next slide. So let's double click on one of those and let's talk about wire management. 80%, yes, 80 of all projects inspected by Heliovolta had wire management issues. Wire management is one of those things that is left open-ended and undefined during the engineering phase that has a huge impact during construction, and sometimes is left to the imagination of a small group of people during the golden row phase. In the previous slide, we were talking about critical issues only. Now we're looking at a whole spectrum of issues, all the way from negligible to critical. There are two charts. The first one on the left shows the 10 most common wire management issues by severity, being the most common wire terminations, sharp edges, sharps resting on the ground, etc. On the second chart, we show the breakdown of issues by severity from negligible to critical. I think the highlight in this data is that most of the projects have wire management issues, but only around 13% are critical or major. And remember, critical and major are the severities that correlate with direct downtime. Therefore, the majority of the wire management issues go unnoticed initially, and they develop over time from negligible to minor, all the way to major and critical, affecting downtime in different phases of operation. Next slide, please. So in this slide, we're looking at a specific example. These are two different projects using the same ATI trackers, large format models, and CAP systems with two different methodologies for wire management. The one on the left, there is consistent well-supported, well-arranged cable management using metal hangers, metal clips, and avoiding attachments to moving parts. It looks beautiful. On the one on the right, we see cables improperly managed and supported, either too tight or too loose. And these, combined with daily movement and a harsh environment conditions, they create a perfect situation for connectors and T-bodies to get ripped apart, cables to get pinched against the torque tubes, purlins, and vertical poles. The side on the right is suffering from underperformance that comes from small daily issues difficult to track. And this is what I call dying by 1,000 cuts. Next slide. The next driver for underperformance are connectors. This is not a new topic. We've talked extensively about this topic in many forums. Unfortunately, we keep seeing this issue happening. So 83% of the projects inspected by Heliobota have connector issues. 45% had major issues, and 4.3% had critical issues. And remember, these critical issues correlate to downtime. And again, the scary part of these numbers is that, or more concerning than wire management, for example, is the highest percentage in critical and major issues. The chart on the bottom shows the most common connector issues observed by Heliobota: connectors exposed to sunlight, water, over torque, under torque, intermittent, cross-threaded, loose, etc. And on the right, we see some photos of examples of what we find in the field. Uncapped connectors sitting on site for months during construction, or improperly made connectors. These evolve over time in overheating and failed connectors that you can see on the bottom right. Next slide. So in this slide, we're presenting a case study where a 100-megawatt project had a thermal event due to failed connectors in the DC string harness after 2 years of operation. The thermal event followed systemic failures that started 6 months right after COD until they had the catastrophic event. This had almost a $2 million impact due to energy loss, full remediation, and other indirect costs. This is almost 20% of the revenue lost that year. That's a huge impact for the IRR of this project. And taking a step back, this distribution is the area that concentrates the majority of the critical issues. And this is where focusing during construction with good technical specifications, a strong QA/QC program will have the biggest impact to reduce future underperformance. Field data has a lot of value. However, you cannot improve it if you cannot measure it. With that, I'm gonna move into a poll that we have just to understand a little bit more how your team does or track construction QA/QC. There's a few examples here. And then I'll pass it to Erin with Radian.
Thanks, David. I am Erin Kiblahan. I'm the SVP of Asset Management at Radian Generation. We are a comprehensive asset management platform service provider, starting early on in the operations, construction design phase, reviewing contracts, that type of thing. We also provide compliance and security services for NERC compliance, FERC, managed security, and cybersecurity and OT, design and commissioning consulting. And we also have a in-house software platform that we use internally for all of our asset management scopes, as well as clients use for development, construction, regulatory compliance, and their own operations and asset management. So next slide, please. Thank you. So Ed talked about early risk mitigation and designing and building for the long term as an offensive way, not offensive, way to ensure that the projects perform as expected and avoid long-term impacts from the types of issues that David highlighted. I'm going to talk a little bit about the early involvement and commissioning and in the commissioning and turnover from EPC to operations, and how that is critical. And it's an often overlooked opportunity for long-term success. This period in time is also the right time to include your asset manager if you haven't done that already in the process. involving asset management early on before COD provides some operational and revenue risk perspective that development and construction teams may overlook because that's not what they're in the business of doing, running plants for 25 years. So asset managers are. So a few stats here. According to EIA, approximately 20 to 25% of utility scale PV projects are delayed from their expected COD dates or test energy dates, which frankly I thought was kind of low compared to things that I've seen. But that number is going down. It was 25% in 2024. I think it was 20 last year. It's driven by all sorts of things like supply chain and permitting and things like that, but it's still really relevant to how we handle turnover. The main factors are really construction and testing related. Anytime there's delays, obviously that compresses the timeline for commissioning and testing and can sometimes create sort of a deal with it later or deal with it after COD mentality for issues that basically end up on a punch list or things that might be a little bit bigger than what we would normally see on a punch list. That's driven, by contractual requirements under PPAs and ESAs, and then financing pressures to get to a certain date to close financing. So sometimes these compressions are necessary, but the approach can lead to a much more significant risk and expensive problems for the long term. No matter how smoothly the commissioning is going and how well your partnerships are lined up, this stage does involve intense coordination between multiple parties, always. So testing, O&M handoff, plant data, equipment commissioning, punch list completion, we've all been there. That can all sort of muddy or obscure critical details that could become issues later on. Some of the common risks we're concerned with, are both in the near and short term are things like physical risk. Is there fire risk, equipment failure risk, any environmental or health and safety risk, civil issues that can only get more expensive over time if they're not remediated quickly. And how do we mitigate that? So next slide, please. This is just an example of 3 major turnover misses that happen really frequently in the rush to get things commissioned. And this is where a solid commissioning and handoff procedure and good partnerships make or break the long-term success of the project. The first is, incomplete handoff and testing packages. Sometimes as-builts are delayed or behind schedule, or changes that were made in the field during construction were never captured properly. Final protection settings aren't recorded properly. Incomplete warranty documentation. Anyone out there who's worked with me in the last 15 years knows that this is my hill to die on and my soapbox, and probably doesn't want to hear me talk about it, frankly. But without that accurate documentation, you're swimming upstream when it comes to warranty claims in the future. And without accurate as-built drawings and any field changes, future maintenance and troubleshooting become ineffective, inefficient, and costly, and frankly can also provide risk or contribute to risk for those operating in the field. Second is no baseline records for warranty claims. If there's missing test commissioning results, or even missing, to Ed's point about wind testing and wind sturdiness, getting the wind tests for your panels and your racking is important. Lack of records for relay settings, firmware versions that we're on, and grounding test data. And I'm a big believer in baseline IR scans to be able to determine a starting point for panel degradation rates or hotspots that you might be seeing early on in the process that shouldn't be there when you're first turning a plant online. Baseline records are not just procedural, they're the foundation of future warranty claims. And the absence of having that data severely weakens the owner or the asset manager's ability to pursue warranty claims down the road or identify long-term issues. And the third is, incomplete spares and obsolescence planning. We talk a lot in this industry about spare parts and what's market and what's important. And having a good plan for that out of the gate is so critical to long-term success. Having an inadequate stock of critical spares can leave a site offline or leave a huge section of a site offline for a really long time depending on lead times. We're seeing lead times get longer as we go through all the manufacturing changes and tariffs and everything else that we're not talking about today. The lack of planning for things that we know are common failure points, like tracker motors, some medium voltage components, communication modules, not having a plan for replacing those. Having a reactive approach to spare parts and if it's driven by a lack of initial planning, inevitably leads to extended downtime and revenue loss when critical components or even sometimes non-critical components fail. Next slide, please. So I talked a lot about some of the major early contributors to underperformance and unplanned cost and how to mitigate some of that risk early on in project development and construction. No project is perfect. So how do we as asset managers and partners to owners ultimately optimize the value of an asset through its lifetime? The first is in early stage and construction. Early involvement allows us to review binding project documents and flag any potential long-term cost drivers for owners before they're locked in. Reviewing things from a long-term operational perspective sometimes gives clarity where there was none before. Reviewing those documents, we can identify potential cost adders in the long term, like non-standard reporting requirements or spare part inventory requirements, and also help clarify and understand EPC deliverables and make sure that they are adhered to on time and within scope. And then during commissioning and in the pre-COD stage of things, the focus is on a seamless transition to operations by setting up the monitoring systems correctly, reviewing technical documentation, and establishing a clear plan for spare parts. Those data connections are obviously paramount to being able to monitor the plant for outages, communication issues, equipment issues, all of that, as well as reporting to off-takers. Reviewing the technical documentation helps manage punch list items carrying into operations and making sure that those get closed out in a timely manner. And having an asset manager familiar with all of that documentation, the warranty terms and procurement contracts as part of the turnover package will save hours of time and money and frankly relationships within the industry when something inevitably fails down the road. Like, clear is the best way to get the right outcome for your plant. And then asset managers can help develop a spare parts industry inventory, good Lord, and budget and the replenishment plan. Not only is this good business practice, but it's becoming a more and more frequent requirement in financing agreements that projects demonstrate an initial cache of spare parts. Asset managers will work with the owners and the EPCs to understand the expectations for baseline spare parts in inventory, ensure any spare parts that were used during construction are replenished, and have a baseline for reordering established through the owner's procurement or the O&M provider. And then in operations, obviously, this is the phase where asset management shifts to active oversight and helping owners make the data-driven decisions that optimize their plants. For example, seeing a small persistent DC health loss issue may not be a high priority from a maintenance standpoint, but choosing not to prioritize that can ultimately be far more costly than even a single dramatic equipment failure at like the inverter level. Performance monitoring, oversight of the O&Ms, and warranty management keeps everything on track and flags any things that are lagging or causing revenue losses. Conducting risk assessments and identifications, prioritization and ROI analysis for unplanned maintenance. For instance, there might be an annual substation maintenance that identifies an issue that's not causing a production loss, but is at a risk for a critical failure. That might not be something that pops up as a priority for the O&M because it's not creating a generation loss at the time, but the risk is there to take the whole plant offline. So asset managers can help identify those and prioritize them and work with the O&M to make sure that those get taken care of before something bad happens. And then also tracking long-term equipment failures across multiple OEMs and multiple plants and regions, and monitor DC health, like connector issues that David mentioned, degradation, things like that. So as a closing thought, proactive asset management is not just a post-construction activity or value add. It's a continuous process of value optimization that begins as early as possible and extends through the entire lifetime of the operating life cycle. So it's something that works hand in hand with owners, engineers, independent engineers, and all of the technical expertise we have on this call. So next slide. I think there's a poll after this. Yeah. So curious to know how rigorous everyone else's commissioning and turnover processes are today. And with that, I think I hand it back over to Colin.
I think so. Thank you, guys. Thank you so much. We can jump ahead to a slide. So these are back to back, and this is interesting information for us to gather too with the group. There's another poll question here, which is just which phase is currently most under-resourced in your organization? This is useful information because, we'd love for you guys to think, where are our shortcomings? And all of these are things that we, this group here can help with in one sense or another. So I'd encourage you, if you do identify an area where you feel like you're lacking, please reach out to us because we're definitely the group that can help fill those gaps. So there's just some conclusive slides. If we can go to the next one here. Want to take all this content and decide or make a conclusion about what it all means. And so, we've repeated this a couple of times, but ounce of prevention, pound, maybe even a kilo of cure, right? So the early decisions that you make are going to influence how your projects perform in year 5, 10, 15, up to 30 and more, right? And having these plans in place is not only a quality issue, but it's also a financing issue. It could block you or preclude you from being able to achieve financing. Field inspections and data analytics are very important. So you need to be able to choose a good partner, and that partner needs to have the right tools for the job. And 4 and 5 here, this is an overused metaphor, but I really look at it like car ownership, right? So like the turnover and the phases of turnover are like having good Carfax and being able to see the history of the car and making sure that it's, that everything's copacetic before you buy or sell. And then number 5, life cycle discipline, preserving the value of your asset kind of goes without saying, right? And then again, it's like changing the oil regularly on your car, right? And just having the discipline there that's going to maintain the value of your asset. Next slide, please. This one here, this is the cheat sheet, and we'd like to be able to share this with the audience if anybody's interested in having it. Quick matrix that puts together the different phases of a construction or a project lifecycle from design all the way through late ops. The different companies that have presented here today and what their value proposition or abilities are for each of those phases. So again, a lot to read here. I'm not going to go through it all, but we'd love to share this with you guys just so you know who to go to for what. Next slide, please. All right, so now with the extra time that we have, we're going to do a little roundtable style, a little bit of questions and answers. So I'd love to encourage also the audience, please submit questions that you have through the platform here on Zoom. I can try to address those too. But I'm going to start off with one that I think will be mostly addressed to Ed, but we can just kind of kick things back and forth with our experience here. Ed, you had a nice slide that illustrated the pitfalls of not having enough borings on a given site and then finding out later that there was soils that were heterogeneous, right? Mm-hmm. I imagine being the EPC contractor and, I'm given this information and I would flag it as a risk, but because there's a lot of times so much hunger in the market to sign projects, a lot of them might, hold their nose and sign, right? And so mm-hmm. I'm wondering when it comes down to it, when you discover that there is, information that's been presented to you that says, oh yeah, all these soils, they're great. But then when the EPC gets out there and they find that that's clearly not true, what are you finding that or I guess what does that cause between your EPC contractor and your owner, and what do you see on the dispute side as an owner's engineer?
Well, it really depends on the contractual language, where that risk lies, but we've seen it where, there's terminology in contractual language, where the EPC is allowed to recover that. Mm-hmm. And then we've seen other issues where, it's pretty straightforward that the EPC assumes all, subsurface risk and they're typically responsible for that final geotech. So
Hmm.
a lot of times it will technically fall with them. However, with that said, we will typically see, owners and EPCs, if there is a major, major issue, there being some sort of negotiation and coming to some agreement on how to address,
Yeah,
on sharing the cost, sharing the risk. Rather.
that makes a lot of sense. I mean, do you find when you're designing an RFP on behalf of an owner, you pay attention to that kind of language? And do you notice, I guess, different levels of discipline from one EPC to the next on their willingness to accept or not accept that type of language?
Uh, as far as your first question, do we pay attention to it? Yes, we definitely pay attention to it. I mean, I think that, subsurface risk is the area that can really materially swing, your ultimate CapEx costs. So we definitely pay attention to it. There are certain parts of the country and certain, maybe pre-flag risks that will maybe heighten that. If there's issues where there's, you know, particularly sandy soils, or if there's issues like in the parts of the Midwest where you have, and I'm not a geologist, but where you have some of these continental plates coming together and can produce sort of, that can produce these variable conditions, we will definitely pay closer attention to it. But I think that, for the most part, we've seen, EPCs and owners being pretty willing to work together. I mean, of course, everybody
That's
wants
good.
to lower your risk exposure,
Right.
but nobody wants to get stuck holding the bag. I mean, a major, major civil risk could potentially bankrupt a small company, depending on, how on their financial position. So nobody wants to see anybody go out of business.
That's right. That's right. Good for the health of the industry.
Yes, it is.
Um, and then I guess another question I have from your content, but this might be more of a crossover between, an answer from you and maybe an answer from Aaron.
Mhm.
Similarly, you showed, I guess, the wind dynamics, right? And from my experience as a tracker vendor, I recall that a lot of times the information that you would get from an owner would be, a certain wind speed and maybe at best a certain wind prevailing direction. And so
Yeah.
much of tracker, I guess, design and engineering is about having a stow angle that faces into the wind, knowing or responding to a prevailing wind direction, east or west. But when that information is lacking,
Mhm.
and an owner is wanting to say to the tracker vendor, well, we never exceeded our maximum wind speed. How come these wind, and we all, your picture illustrated it well. It maybe more the behavior of the wind coming from an unexpected area, coming from the upside, right, or the backside of the tracker that might have caused it to fail. And I guess, Aaron, I'm curious if you have any insights on what you see similarly, like in disputes between tracker vendors and owners when it comes to who's responsible for that failure mode if it's ambiguous, whether or not there was proper information on the front end.
Well,
Yeah,
uh,
I've seen a lot of
Please,
different
both of you.
types. I've seen a lot of different types of claims around, not even just warranty claims, but also just, trying to troubleshoot and figure out why trackers are behaving the way they're behaving. It's not necessarily a problem from a warranty or a defect perspective, but more of a trying to understand the interpretation. And obviously, trackers are very sensitive to fluctuations in the landscape. Like flat is better, and all facing one direction is better. It makes it much easier to do all of the documentation and testing. But to answer your question, I think that going back to my kind of repetitive point in my presentation, I think it's really important to have all of the documentation, not only of any testing that was done and any like commissioning testing that was done by the tracker manufacturer, but also MET stations are huge for being able to document, like multiple MET stations are huge for being able to document wind speeds, wind directions, and really understanding, like, is one block behaving differently because there's some weird way the wind is blowing on that site. Like I've seen sites
Mm.
that particularly like in the Southwest, that have really strange wind patterns, frankly, where, one block will go into a stow mode and the other won't. And sometimes it's not a matter of the tracker being the problem, it's a matter of just nature. But
Being
without that
tricky.
documentation and without that data, you can't make that determination. So again, I think it comes back to the data. Does that answer your question?
Yeah.
I
And
think it does.
to piggyback on what Aaron said, I mentioned earlier, I will come back. We've been asked to come back after COD, sometimes years after COD, because the owner's having issues with the tracker, and we will work on those root cause evaluation, root cause analysis of the issue, and the lack of data does tend to be an issue. You typically start with the design assumptions, right? Was the tracker designed for the environmental conditions? That's the base analysis of it. Then you move on to, um, is it a materials issue? Was it designed correctly, but did the materials not meet the assumed strength in the analysis, right? And then if it's not a design issue, it's not a materials issue, then it looks to, is it an installation and commissioning issue, right? And that's where typically, I would say where I won't say protections, but the documentation requirements and the contracts aren't always specific, or in the turnover packages that require a lot of that data, that documentation to be retained, so that when you perform the analysis, sometimes it can be a challenge to really hone in on what the issue is because of lack of documentation. And that goes along with the material certs for the racket for the components, which is also critical to evaluating whether the materials met the required qualities.
That makes sense. Thanks, guys. David, I got one for you too, maybe a few for you. There was some staggering stats you gave, one of which stood out to me, being the 80% of connectors seem to have some type of issue or latent failure, or at least latent problem. And I guess what occurs to me when the number's that high, it makes me think, not looking at what did they do wrong, but what about the other 20%, and what did they do that was so right? Right. And is it reasonable to expect that you can be part of that 20%?
Yeah, no, that's a great question. I wonder that every time. I think there are a few contributing factors that I think the history on the code that has been contributing to the confusion about connectors and compatibility for many years. So it was not that many code versions ago that this was very strongly clarified that you cannot cross make connectors. And I think as an industry, we've seen the effects of the past deployment of projects with issues with connectors slowly trickling as the sites get operational. These are usually slow burning issues that are missed, or they go under the radar for a long time, and it takes a few years to surface. And usually it starts with a small overheating through the different several cycles until they kind of go into thermal runaway and really fail catastrophically, and you see the consequences. So again, going back, I think there are things that we can do as an industry, and the ones that are like meeting that criteria of the 20% are companies that are taking this very seriously, doing a lot of planning ahead of time. And again, this goes back to the solar coaster overall. When you have to make decisions on your supply chain and you decide to buy solar modules from X company last minute, module manufacturers didn't, still today don't specifically specify the connectors that are coming with the models. So now you start having to deal with last minute supply chain constraints where it's like, oh, I need to go find the connectors that are going to meet these model manufacturers' connectors, and every model manufacturer now comes with their own connectors. There are 180 different brands of connectors out there and types. It's a difficult problem, and everyone thought that because they were compatible, everything was good, and now we're seeing the consequences. So it's going to take a few cycles of the code to get us back on track, and also for companies to be diligent about, the procurement, planning, engineering, specification, etc.
So then it's fair to say that the 20% aren't lucky, they're disciplined.
Yeah, I mean, totally. I would
Yeah.
say so.
Okay.
Yeah.
Great. Great. It kind of leads me into something else to ask of Aaron too, because I mean, you brought up something about what delays, having to rush, buy what's available, cobble together. And Aaron, you were talking for a little while about, I think you said something like 25% of projects are delayed, right? And of course, any delayed project, there's a financial penalty with that. Everybody's rushing. So are you seeing that those projects are more rife with certain types of critical failures? And is there any failure that's more common than others?
I think it depends on why the projects are delayed and why they're rushing. I think I mentioned there's, myriad reasons a project can be delayed. And this is that statistic is based on historical EIA data that takes all of the considerations based on estimated in-service date into consideration. So things like supply chain, all of that. The ones that I was focused on, and to your question, the construction and testing delays. Yes, I think there are some things that stand out. I think one thing that does get rushed at the end and is often difficult to come back to as a punch list item because of the nature of the work is civil. I mean, Ed did talk about civil quite a bit, proper compaction of roads, proper burying of cable, proper depths, things like that. And sometimes when you're rushing, that also leads to one of the other things that I brought up, which is, or one of the other points that changes will be made in the field, and they're the right changes to make, but they don't always get documented properly, and that can cause both safety and generation issues in the future. The other thing that I think we see a fair amount is rushing to not rush it. That it sounds bad. I'm not trying to make it sound bad. It's the nature of what we do. But accelerating testing timelines and getting things enough over the line to be accepted for COD and to meet the minimum requirements for final completion under an EPC agreement. They don't necessarily always, and this goes into the compliance realm, which is not what we're talking about here, but they're not always comprehensive enough to give us the data we need down the road to understand how there are like as left settings and what settings were changed and why, and just a lack of more information that in 2 years, everyone from that EPC crew, everyone from the testing crew, everyone from the permitting department, they're all gone, and no one remembers what someone said on site on a Tuesday morning at 7:30 in the stand up. So I think it's the biggest issues are really around things that cause long-term failures. Sorry, I'm rambling, but the other thing that we see is cabling, wire management, rushing wire management, getting stuck in trackers, things like that cause long-term, more widespread issues. A lot of the things that David talked about, connector issues, you can't test every connector on a site during commissioning. You just can't, but you can make sure that you're taking a much larger sample size than a lot of customers actually do to ensure that there's not, an issue over here that wasn't caught over here because you only did one block or something like that.
Mm-hmm. Great. Thank you. I also want to acknowledge we got a question from the audience here. It is about energy modeling, which I spoke to in the beginning, but we can touch on it again. The question is, regarding design, what percentage of assets do you actually see achieve the P50 generation forecast? What modeling scrutiny do you implement to increase the likelihood of achieving the forecast? So I should mention again, today's webinar was focused on physical issues, right, that manifest later. I guess energy yield assessments and auditing them is certainly a service that Enertis provides, not only for P50, but for P90s and more accurate ones. And we have another team that can address that. The nature of this question, so one thing that stands out to me is, of course, P50 is by nature less accurate or mature, right, than the later stages of generation forecasts. But Aaron, would you ever see a history of the forecast being P50s, P90s, whatever, and how often the generation at the site is reaching what those initial forecasts were?
Sorry, the question is, do we ever see the
Yeah,
forecasts or
I guess, do you see the history of, the P50 forecast that was the original forecast and whatever the generation is currently? And do you have a general sense of how often it's hitting that mark or
yeah, we
falling short?
see well, I mean, it depends on what the client provides, obviously, but we
Yeah.
generally will see the energy forecast at both P50 and P90. Um, we go off of the expected energy models to do our performance analysis. And that is kind of set by what the whichever metric the owner wants to use. It's not always the
Mm,
same. This is actually a really great question, and I I wanted to pull more information on how often projects do hit their models prior to the webinar, and I went down a immense rabbit hole over this because we do have all this data for because we're reporting on all of the performance for all of the sites that we manage across the board, regardless of whether we're using P50 or P90 or some other number. And the aggregated, very, very, very high level data I have over the last year basically shows that the majority are somewhere between 90 to 100% of whatever modeled expected energy we're using. Now, the issue with comparing that to just energy modeling is that this is weather corrected, but I don't believe that it is curtailment corrected. So in some
mm,
areas that have heavy congestion, heavy curtailments, some areas that are, are have market components, merchant components, things like that. There's some changes to that. I'm not entirely sure, to be perfectly honest, what this is
mm.
capturing. And some of it has to do with, utility outages, or was there a major substation outage or something like that. But I would say that on average, 50% of the projects are within that 90 to 100% range. A very small percentage are above it, which is always good to see.
Hey, yeah.
Maybe I don't know. I guess ask your modeler how you feel about that. But and then the other 50% are below that, and I think a
Mm.
lot of that has to do with things like spare parts.
Yeah, yeah. And that's a
That's my
significant
soapbox.
amount. That's right. That's the soapbox. You're up there. Thank you so much for that. And we have, our audience members' contact, and we also encourage you to touch base with us if you want some more detailed information on that. We'd be happy to share. I guess maybe we have time for one last one. David, I want to pull you back in here. There was another slide where, I mean, you were showing the occurrence of certain types of failure modes. What stood out to me was thermal failures and hotspots made up the vast majority of the failures that you see. And you also showed a map that really touched points of all the different projects where you guys do your work, right? Heavily in the Southwest, the Northeast, the Southeast. And I'm wondering, are any of those failure modes more present in a given environment than another environment? Or anything that you could attribute to where a solar field is versus what goes wrong?
Yeah, it's a tricky question. You have to because the data we're showing, that's for operational assets. And when you
Mm-hmm.
are failing thermally, it's already too late. Like that's the final symptom of some type of other problem early on.
Mm-hmm. Mm-hmm.
So it has the weather and the climate has an effect for sure. You go to climates that are like way harsh, or have daily thermal cycling with very high temperatures during the day, lower temperatures during the night, and that really affects the way things degrade over time. I don't have data specifically. I mean, it's a good exercise to do, but I don't have it by region. But I think what we will see is that there's probably it's pretty independent at that point. At that point, you already have like a fail component. So, I think is I would say, I mean, a good exercise to do, but I think it's spread out all over the country necessarily. When we see like these failures, it's not there's a specific area where we're like very surprised that it's happening all the time. I mean, I have
I
to say,
see.
Puerto Rico and Hawaii are different animals just because the high temperature, high humidity, you always see higher failure rates on many things. But I think the rest of the country, yes. I mean, you have the effects of snow in the Northeast and, harsh climates like Texas sometimes. Uh,
All
I'll,
right.
yeah, I'll wrap it up here. I think we're on time.
I think we are too, but thank you very much for that. That's insightful, knowing where there's maybe more risk factors for those island installations, for example. Everybody, thank you so much for joining us. I hope you enjoyed the content. If you have any additional questions, never hesitate to reach out to me or any of our panelists today, and we'll see you next time.
Yeah, thank you, everyone.
Thank you, everyone.
Thank you.